Hi everybody, I wanted to do a tutorial on arithmetic operators. Also, since Studio Project 3 is going to be your first project that you're going to be programming, I wanted to program the stuff that I talked about in the operators lectures and show you some of the stuff that I have done. So let's do a quick example of integer division. Let's say I have int x equals 5 and I'll have int y equal 3. And let's say I'll have int c equal x divided by 5. First of all, if I run this code the way it is, and you notice that I don't have a semicolon here, I'll get an error. What processing does, it shows one error at a time. So if you have multiple errors in your code, the processing will show one error at a time. So you fix an error and then it'll give you another error if you have more errors in your code. Therefore, it is very important that you guys exercise something called piecemeal programming. What piecemeal programming is essentially writing no more than 2 or 3 lines before running your code, making sure it runs. The worst thing you could do is to write an entire program and you just type away and then you try to run it. It's just going to be really confusing for everybody to figure out what went wrong if there is a mistake. So, for example, if you are missing a semicolon here, you get an error. This is called a syntax error or a compiler error. The reason for that is that recall that the compiler is going to translate your code to machine code. If something is missing, if a semicolon is missing, then the computer cannot translate it. And remember, the computer is really concise. It's not going to make assumptions. It's going to say, well, I can't translate this. A semicolon essentially means an end of a statement, an end of a sentence. So unless you put a semicolon there, the computer doesn't know that you're done. So it's not able to, basically, it's not able to translate it. So I'll put a semicolon there, and then you see the code running. And the way you know the code is running is with this screen that pops up. Another thing that it's not just semicolons that make for syntax error. For example, if I'm missing this equal sign here, and I try to run, the computer says unexpected token int. Not all the compiler messages will make sense. Some of them are more, they make more sense than others, but nevertheless, an error is an error. Another form of syntax error, if I, for example here, if I said C equals A divided by 5. This is going to be a syntax error. Why is that? The reason is I have not declared A. If I have not declared A, how could I use it? So I can't have A here unless I have used A. I've defined A and actually initialized it as well. So let's give it a value, for instance. Now everything runs, right? So you have to watch out for this. When you're programming, take your time. Make sure every time you write a couple of lines, compile, make sure it works. If you have questions, ask your peers in the studio, ask the TA, or ask your instructors and the TA coordinators, whoever is around. Make sure that you get your problems solved right away. So piecemeal programming, very, very important. Let's do a couple of examples with these. So let's say we have to int x equal 5 and y equals 2, and I'll have double A equals 6 and B equals 4. Okay, so if I went ahead and said println, and I said println, and I said 5, sorry, x divided by y. So this is int division. The result of this, of course, if you run it, it's going to be 2. So 2 goes into 5 2 times. So x is 5, y is 2. Because this is integer division, I could also go ahead and say x modulus y. And if you guys have watched the lectures, you should know this now. So x modulus y, that is, I'm saying if I divided x by y, what would be the remainder? So the division here will get the quotient, where the modulus will get the remainder. So this gets the remainder. So let's run it. I have 2 here, and so I should have a 1 printing underneath 2. There we go. So 5 divided by 2, the remainder is 1. Okay. Let me take these 2 out, and I'm going to say print ln. Now a, which is a double, divided by 5. Sorry, divided by x. Okay, this is now real division. As soon as you have a double or a float involved in division, it becomes real division, right? So this is real division. The result, of course, is going to be a is x, so so 5 divided by 6. I'm glad I'm doing this on the computer because it's gonna be so 1.2. That's the result. Another cool thing that I wanted to show you is, what if I said print ln x divided by 2. Okay, is that integer division or real division? Let's see. So that's 5 divided by 2. We get 2. So that becomes, this is also integer division. Well, let's do something else. What if I said this time, instead of saying x divided by 2, if I said x divided by 2.0? What happens now? Let's see. So now we get 2.5. So computer views 2.0 as a double. It treats it as a double, even though it's not a variable, but the data member itself is treated by the computer as a double. So if you get excited about programming like I do, this is pretty cool. This is how the computer recognizes different data. Typecasting, again, is not a huge thing in this course. It's not a huge topic in this course, but again, it's a cool thing where you get a data for a point of time to become something else. So, for example, if I wanted to say print ln, and I wanted to say x divided by y. So I showed that this is, if I run this is going to be integer division. I'm going to get 2 here. If I just made any of these, doesn't matter, one of them or both of them, if I went ahead and I did some typecasting, that is, if I put a double here and I run it, now all of a sudden this becomes a real division, right? So this is because of typecasting. This is now real division because of typecasting. But of course, don't forget that y does not become a double. It's just treated as a double in that instance of time. So also, with regards to print and println, I'm sure you agree that they're really useful because you can see what's inside of the variables, and you can also put little math expressions, arithmetic math expressions inside, and it prints it out so you can kind of see what the result is. So they're really, really useful. One cool thing of println, so if I wanted to see what's inside of x, obviously I would just do this, and it would show 5. But what if, a really cool thing is if I wanted to see inside of quite a few variables, I could have multiple printlns, but I could also do like this. I would say, so show me what's inside of x, comma, y, comma, a, comma, b, comma. So like all of them, right? And when I run this, you see all of them show. So I have 5, 2, A and B are doubles, so they're actually shown as 6.0, 4.0. In reality, they're represented as 6.00001 or 2 at the very end. Like I said, they're not very precise. But you can kind of see this. The danger of this is you may lose sight of which variable is being printed because they're being printed in order, right? X is printed first, then Y is printed, then A, then B. So processing is actually not really about this counsel down here. So this is the counsel in a lot of your quiz questions and your lectures that say counsel. I already said this, but make sure you know that this is the counsel basically. Processing is not really about the counsel. It's actually mostly about this window that keeps popping up and I keep closing. So in your third studio project, you're going to be drawing things on this little window, making it bigger and do a whole bunch of exciting things, and we keep going on that. But to know what's inside of your variables and to debug your program, meaning to find your mistakes, make sure everything is working the way you want it to work, you need these println statements work really well, and we're going to make use of them. Okay, well, good luck programming. I hope I know you will. I hope you enjoy it as much as I do. And Emily and I are quite excited that this is going to be our first programming lab. Thank you very much.